Assalamu alaikum everyone. Here I am again with another episode of discussing the paper 3. In fact, how to attempt paper 3, and there are so many varieties, guys, believe me, while you are attempting paper 3 right in front of the apparatus in the real examination room. In my previous videos, you have witnesses. I have explained various methods of measuring different physical quantities. Now I am moving towards another very important idea. The biggest confusion, I used to call it a biggest confusion in paper 3. And why I am calling it the biggest confusion or unclear, perplexed, disoriented, lost, confused reason? Because when, as an examiner, even while judging my own students in my colleges, wherever I'm teaching, when I used to check the paper 3, particularly at one area, the way of writing an answer, although with the series of instructions and commands during the practice session, students still making mistakes while attempting that particular part. So I used to call it the biggest confusion. And just on a lighter note, it is called, I guess you will understand what I am talking about. There is a sign of percentage with a face of a person who is not sure what he is thinking, and that's called percentage uncertainty. And I used to call it idiots, two idiots. Again, on a lighter note, why I used to call it two idiots? Because this is one particular area in paper 3 which make my students looks like or behaves like an idiot. Despite of constant reminders, practices during the real ground or real sessions in on a physical ground, still students are making mistakes. So please, for God's sake, do not make mistakes while writing the answers for percentage uncertainties. I have figured out two distinguished methods to write down the percentage uncertainty. The two idiots, how to deal with these two idiots. All right. Method number one, percentage uncertainty or error is supposed to be the least count of measuring instrument divided by the measured value multiplied by 100. This particular method, least count of instrument divided by measured value multiplied by 100, is used when you are dealing with a physical quantity which does not require repetition and it's being measured once only. Be careful about it. Method number one. Method number two, percentage uncertainty, half range of repeats divided by average value multiplied by 100. This particular method is used for all such quantities which are expected to be done with the trial error and trial method. Means you repeatedly measure a one quantity, write down all the answers, get their average, and then try to write the percentage error. For that, we have a exclusive method, half range of repeats divided by average value multiplied by 100, where the half range stands for max value measured minus min value measured divided by 2. Therefore, the full uncertainty must be provided. You can see the formula here. You can note it down as well. Max value of x minus min value of x divided by 2 in numerator. In denominator, you have average value of x and then whole multiply by 100 to make it a percentage. And always remember, percentages must be provided up to a whole number. If I am getting 19.67, I might take it as 20%. Or sorry, let me write it in a decent way, 19.67%. So I will use this notation and I will declare 20% range. I'm getting 0.982%. I am suggesting 1%. Percentage should be rounded to a value. Always remember that. Okay, so these are the two methods. Method 1, when you measure only once. matter 2 when we are measuring many times and take and repeat. So now let's take some examples how we gonna deal with the percentage uncertainty in the variety of situations. I have witnesses many physical quantities in paper 3 where examiner is expecting the student or a candidate or an experimenter must write down the percentage uncertainty as well, and it comes up with a proper idea I have just mentioned in the previous slide. So guys, buckle up. I am discussing one by one the possible ways how the percentage uncertainty must be provided in the script of question paper. All right, so let's take number 1, angles. If we talk about particularly angles, there are not many, like 4 or 5 I guess. So let's discuss here in this video. We will discuss angles and I guess distances. Number 2 is on distances. Let's see. Anyway, measuring angles. First of all, let's say measuring angles. Here is an example now. Measuring 2005 paper 3. Question number 1. A setup is there. Determine the percent density in the value of theta, and theta is measured between 2 threads tied up at support and one with the Newton meter. Percentage uncertainty in theta. What answer we are expecting? Let's see how the mark scheme suggesting us to write an answer. Oh wow, oh my god, are you gonna write the whole paragraph? Absolutely not. This is not supposed to be written, this all not supposed to be written in this tiny space here. What you are gonna write down, let me tell you. First of all, let's read a mark scheme. Absolute uncertainty starting from 1 to 5, 1 degree to 5 degree. For that you will get 1 mark. Then percentage uncertainty in the first value of theta, ratio idea, multiply by 100. What is the ratio idea? 1 mark. A bald answer with no working score, 0. Check values if absolute uncertainty given but no ratios. Allow half range, divide by average value, multiply by 100. See what I am talking about. If a candidate is using a repeats, if it is for the sake of hardly 1 or 2 marks, by the way, if a candidate is using a repeat method, then a range method is allow the range method. Otherwise, if he has mentioned just one value of theta, because obviously when the system is in equilibrium, this thread is going nowhere, it will be stagnant. Yeah, perhaps it happens when you put the protector here, the string wobbles and you might face a little difficulty, so you can have a theta 1 and theta 2 or perhaps theta 3, take an average. If you show us an average, then it is allowed. You will take, first of all, percentage uncertainty, give us the full ratio idea. See, ratio idea must be mentioned with the, but check value of absolute uncertainty given but no ratio. Okay, what does it mean? It means delta theta upon theta multiply by 100 we are expecting, where the delta theta is what? Okay, the delta theta is least count of protector plus at least thickness of thread. This is delta theta. Let me down, not delta theta, least count of protector plus thickness of thread. Reason, when you put the protector here and try to measure the angle, the opaqueness of the thread might hide a divisions on the protector. If the thickness of the thread is that much, it is covering 2 divisions on the protector, or either 3 divisions of the protector, or either the 0.5, half of the division of the protector. It all depends what type of thread is given. So least count of protector is 1, thickness perhaps 1, maybe 2, maybe 3. When you sum up all, let's say if I sum up 1 and 1, I'm getting 2. or I'm getting 3, or I'm getting 4. Look at that. They have mentioned a range, the absolute uncertainty, which is delta theta. The delta theta is an absolute uncertainty, should be in a range. Any one value is welcomed. Delta theta is his, right? Delta theta. So mention the delta theta absolute value. This one. Now give us the percentage. Delta theta divided by theta multiplied by 100. Put down, let's say 2. Angle is, let's suppose, to be 120 degree. Multiply by 100. Whatever the answer is coming, write it down over here. But for God's sake, always mention what you are claiming about the absolute uncertainty for a measured value. The absolute uncertainty must be mentioned clearly. And why they have giving us a range 1 to 5? Everyone knows the protector has a least count of 1 degree. So why not they have just mentioned absolute uncertainty equals to 1? Why the 5 is also written here? Okay. So be very careful and be very practical. We are concerning the ideas, possible ideas, how a student will face a difficulty while measuring something. It must, that level of difficulty comes under the idea of absolute error. This is not a theory paper. Again, I am repeating, you are not solving paper 1 and paper 2 here. For paper 3, absolute uncertainty has a variety of ideas, and you have just witnessed one of it. You got this? Thank you. आगे बढ़ते हैं. All right, let's move forward. Let's take another example now. May June 31, 2009. Angle of tilt has to be measured. Again, angle with theta with an angle with the proper SI unit, and estimate the percentage uncertainty in theta. This is in this situation. Most of you have witnessed this situation when the bottle topples itself under its own weight. The moment it starts toppling under gravitational effect, what is the last angle made by the bottle? And that's a hell of a task, by the way. And obviously nobody can have a secure value of theta. It will always be a confusion. So you might take a theta 1, theta 2, theta 3, theta 4. Let's say I'm witnessing somewhere between 40 and 50. I take it 42. Next time I witness it is somewhere between 45 and 50. I take it 47. I take it 51. I take it 43. I take it 45. Now I will take the average for all of it, right? I am getting the average. Let's quickly let me get the average. 42 plus 47 plus 51 plus 43 plus 45 divided by 5. I am getting 45.6. So I am writing 46 degree. The average is 46 degree. Now, how to write the percentage uncertainty? Now, delta theta. First of all, I will write the absolute uncertainty. It's called half range of theta. So the half range is my highest angle recorded is 47 minus the low, no, sorry, it's 51 minus the lowest angle recorded is 42. So 51 minus 42 is 9 divided by 2, which is 4.5. Therefore, the percentage uncertainty is 4.5 divided by 45.6 multiply by 100, and whatever I am getting is 4.5 divided by answer into 100. I am getting 9.86. So I am taking the uncertainty as 10%. If I am in your shoes, this is the way I am going to write the percentage uncertainty in the exam copy, guys. Trust me. And this is the method you will gain a full credit. I hope you understand the idea about the angles. All right. From the marks team, see that again why they are not using the precision of a protector, which is 1 degree. Why they have given us a range. And secondly, if repeated readings have been done, that can be the half of the range, and use of the correct idea ratio can be implied. See the mark schemes. take a lesson from the Mars games. Why they are mentioning a range for the absolute uncertainty. Different candidates may have different range of thetas. So the amount of uncertainty would be different. It's 4.5 in a range, perhaps still in a range, because we know we have all the dimensions of the bottle, we have all the measurements of the liquid, and we exactly know in what range the bottle is gonna be topple. Do not think examiner knows nothing, he knows. So do not just assume that whatever you're gonna write it's supposed to be correct. No, it's supposed to be in a particular range, the answer must be in a particular range. So this is all about dealing with the percentage uncertainty in theta. Quite in detail, I have explained this almost more than 15 minutes now, right? So in inshallah in my next video we are going to cover number 2, and that is again a very important idea. Number 2, I let me just give you a little trailer for that, measuring the height, distances, gaps and thicknesses, which I will cover in the next episode inshallah. Thank you very much.